Hi everyone, and welcome to my first session for today. I'm going to be pre-recording this session so that you can ask me some questions on the channel while this is running, and also just for to alleviate some concerns around bandwidth when presenting the session. This will be the first one of two ones that I do today. The second session will be on availability and resiliency patterns for the cloud when you build systems. So if you're interested in finding out how to make your apps more resilient, come listen to my talk on the 6th track at about 4 o'clock today. But cool, let's get started with this talk. So automating your cloud, what are the building blocks? So before we get started, I just quickly want to answer one question that keeps coming up, seeing as I work for AWS. And this is what our global infrastructure footprint looks like at the moment. And you can see that we've got an upcoming region for Cape Town. So I constantly get this question, especially when I do conference talks, like when is the new region coming? And to just get rid of that right now. So it's still planned for the first half of this year. If you've got any further questions, please ping me afterwards. I'll have a final slide with my Twitter and LinkedIn handle. You can ask me questions there. So firstly, a little bit about me. My name is Cobus Bernard, and I'm a senior developer advocate for AWS. So I was a developer for about 15 years before I joined AWS, and of those, for the last 8 years, I was an AWS customer. So I've been building systems on AWS, and a lot of that focused around how to build cloud-based systems and also how to automate a lot of the work that you kept doing over and over. So basically, when I started thinking about this talk, I thought, well, a lot of people want to go to cloud and there's a lot of scope for automation, so let's help them with it. And I pretty much love to automate everything. So let's take a look at what the agenda is going to be like for today. So we're going to start off with a couple of definitions just to quickly clear up what is DevOps and what DevOps isn't. Reason for this is that I'm very involved in the DevOps community locally, run the local Cape Town DevOps user group, also co-organize on DevOps Days Cape Town. And there are a couple of misconceptions around it, so I just want to quickly clear that up before we get into the meat of the actual presentation. We're going to then take a look at infrastructure as code, and then I'm going to show you how to build a golden path for your developers for both VM images and for containers, and what that means and why we'd want to do that. Then we're going to move on to a little bit of a look on deployments and how to handle those. And then lastly, in between all of this, we're going to look at configuration management and how you actually bring this into your pipeline and where do we sit with services like Chef and Puppet and Ansible and how to use them. So quickly starting off, DevOps. So the first one here is that DevOps is not a sysadmin who's now building systems on the cloud. It's also not automating the cloud. And lastly, it definitely isn't just about building CI/CD pipelines. Now, the best definition I know for DevOps is the abbreviation CAMS, which stands for culture. So the first part is that you need to change the way your organization thinks about software and delivers software and works together as a team. Because if you have all the tools available, but you still are working with old mindset of, let's say, waterfall, where you want to be able to predict everything for the next 12 months perfectly and you can't adapt, it's probably not going to go that well for you. So this entire culture change about, for example, being curious about figuring out if something goes wrong, let's rather figure out how it went wrong and what we can learn from it than trying to blame someone for when something went wrong. The second part of that is what this talk is about, is automation. And I'm just going to touch on a couple of points there. Now, just quickly with automation, I'm sure some of you have had the concept of a playbook for configuring a server, where you get this nice thick document that has a couple of hundred pages, or not a couple of hundred pages, sorry, a couple of hundred steps in it, and you have to follow the steps exactly, otherwise something will break. I've been in this situation, and one time I had one where the whole playbook fell apart at about step 260 or 270. And we got really stuck because the person that had set up the playbook had left the company. And it took us, I don't know how many days or weeks to actually figure out how to fix that thing, and then finally set up the server, which used to take like 2-3 weeks just to get it perfectly configured the way we wanted to. The third part of DevOps is that you want to measure things. The reason is that, let's say you're trying to improve your build system and you didn't measure anything. And then afterwards you go to your manager or the person running the company and you tell them, basically, I made things faster. But you can't show them how much. You just said, wave your hands, it's faster. They're like, okay, that's cute. How much faster? The second part of that is that if you haven't measured exactly where your system is slow or where your system has bottlenecks, you might not be increasing speed where it matters. A good example here that comes from the Phoenix project, which is a book I'll recommend at the end of the deck, is that let's think about a car production factory line. You might have a couple of systems that in parallel produce all the different parts for the car, and then you've got a central point where all the parts come together, and then there's a system that takes those and puts them on the frame of the car. Then that goes on to the conveyor belt, and then there are parallel lines again where multiple different robots and people weld and assemble everything. Now let's say the slowest point in this entire system is that point where it takes the individual parts and put them on the frame. And you then decide, I'm going to go speed up how we produce the parts. The only thing that's going to happen is the parts are going to pile up before that machine that actually puts them on the frame. Then let's say you make a second wrong mistake, which is you decide, okay, let me go work on those conveyor belts where the welding and the people assembling the cars work and actually make that super fast. That also doesn't help, because at the end of the day, that machine in the middle can only put the components onto the frame at a certain speed. And at the end of the day, if you look at the factory output, which is how many cars leave the factory, that number didn't change. No matter how much effort you put into the conveyor belts at the end or at the assembly parts in the beginning of the system, the actual bottleneck in the middle. And that's why you need to measure. So make sure you're actually improving the areas that need to be improved. Then lastly, sharing. A lot of DevOps is about learning things and understanding new ways of doing it. So please share the knowledge inside your organization and outside. And a nice comic that illustrates this is from XACD, which is this one. So let me give you a few seconds to quickly read through it. Cool. So for those who are part of the lucky 10,000 for today, what happens when you put a Mentos inside Diet Coke or Coke Light? Well, basically this. What you can see is that the gas immediately comes out and you get this nice foam stream, and you can use this to make interesting rockets and have a lot of fun with. So if you haven't done this before, please go do this. It is a lot of fun. It is messy though, so be warned. So cool. What is our goal with automation? Well, to a certain extent, it's fairly simple to define. We want to have our developers and our sysadmins and everybody that's part of the chain building our application to be super happy and not have to worry about things. And the way we tend to achieve this happiness on one part is, once again, let's automate as much as possible. That means we can focus on what's important, right? Well, it tends to be a little bit more nuanced and complex than this. So once again, from XACD, there's this lovely graph over here. And basically what it boils down to is, in theory, you start with the idea that says, I'm doing something that's repetitive, and if I automate it, it'll make my task actually go faster, and that'll actually free up a lot of time afterwards, and then I can focus on more features. What sometimes then happens, and quite often happens actually, is that you spend so much time on that automation part to figure it out that you spend more time than it would have taken you to actually just do the feature without the automation. And once again, same comic strip, XACD, has got this nice grid that shows you how much time should you spend on automation. So what this grid does is, if you look at the x-axis at the top, it asks you how often do you do a task. Do you do it 50 times a day, or only once a week, once a month, or once a year? Then on the y-axis, it asks you how much time do you save by automating this task. And then we've got increments 1 second, 5, 30, or a day. Now let's see what exactly that means. So let's look at this specific cell over here. So this is a task that I do daily, and it takes me 30 seconds. If I spend more than 12 hours automating this task, I would have saved less. I would have only saved 12 hours over the next 5 years. Now, take into account not everything that you build now or do daily you might do for the next 5 years. You might only do it for the next 1 year or 2 years or 3 years. So over 5 years, if you spend 12 hours to automate it, you break even. So think carefully about how much time do you invest to automate it, and is it something that needs to be automated? For example, if we look at something that we do 50 times a day, even if it only takes 1 second, we can spend up to a day, because that's how much time it'll save us over 5 years to do. And then lastly, a nice one in the middle, which is an interesting one, something that we do daily that takes us 5 seconds. Now that might be annoying, but if it takes us anything more than 2 hours, we shouldn't be automating it. Because yes, I understand that 5 seconds daily is annoying, but you're not going to save that much time over the 5 years. And also remember, if you've got 50 or 100 of these tasks, imagine how much time you're going to be wasting by trying to automate something that doesn't really matter. So we're going to touch on that as well later. So firstly, we're going to talk about building block automation. And the first point to start off is with automating your infrastructure. The reason is that probably all of us have some kind of infrastructure that we want to run our systems on. And if you set that up by hand, that tends to be a little bit error prone if you can't remember exactly what you did, or if you didn't keep notes. So let's take a deeper look at that. So what is infrastructure as code? Well, it is where you define what your infrastructure looks like in a text file that you then treat the same way you would treat your code. For example, you commit it to a version control system, you have your peers review it via, let's say, a pull request, and then ultimately, once the pull request is merged, it goes through some kind of CI/CD pipeline where it is deployed into your various environments automatically without you having to do anything. And it also means that you don't go and change your infrastructure by hand by clicking around in console or making API calls with a CLI tool on your own. So a little bit of background here. So initially, when infrastructure as code tools came out, they were using imperative language. And what we mean by this is I will tell you what to do. So think of bash scripts where you go, do this, then do that, then do that. For example, download this one file, then unzip it, and then install it in a certain location. The problem with doing it this way is that you work with a specific assumed starting state. And if you didn't have the exact same starting state, things might go wrong. So let's say that same example, for some reason, the download file, the name changed, or the way you create the load balancer changed. Your system would, or your scripts wouldn't be able to handle it because now that state is different. So what happened over the years is that the tooling changed to be more declarative. And what we mean by this is that I'd rather, I'm me telling you what I want. I don't tell you how to do it. So I tell you I want a load balancer. I want 5 instances behind the load balancer, and I want a specific network layout. And then the tool figures out, how do I go from where I currently am to what you just told me what you want? And that's what we mean by using declarative language. So if we take a quick look at a typical VPC layout spread across 3 availability zones, this is kind of what you can expect. There's some public subnets, private subnets, internet gateway, a couple of NAT gateways, different IP ranges associated with subnets, as well as the entire VPC, etc. So there's quite a lot of components that you can see over here, and there are even routing tables and routing rules. So this seems like something fairly complex. Good news here is if you use infrastructure as code, you can really simplify this. And for example, VPC networking is a very good place to start because all of this complexity, you can boil down to a single line. So what I'm showing you over here is a sample code from the AWS CDK tool, which allows you to define your infrastructure in a language that you're comfortable with. You can use JavaScript, TypeScript, C#, Java, Python to actually define it. And even as a person who's never used this before, if I showed you this as a software developer, you'd be able to read that one line and say, okay, cool, it says constant VPC, okay, defining something, I'm instantiating a new EC2 VPC network. And it looks like I'm giving it a name DevConf VPC with 3 availability zones. So you are able to understand that and actually use that. The line below it, for example, is how you would spin up an entire ECS cluster using that VPC. So you can see here, this is very easy to understand, and this is not something that's difficult if you are not someone familiar with infrastructure. And if you have to come review this, you'd probably know what's going on and are able to fiddle this a little bit. Now, if you didn't want to use the AWS CDK, you could also use something like Terraform, which I also used for quite a few years before joining AWS. It's an open source tool by HashiCorp. Now, this is what the syntax looked like if you used a publicly available module that wraps all that complexity into this abstraction for you, where you define the CIDR range for your VPC, give it a name, tell it what availability zones, and give it a bunch of subnet IP ranges for, a bunch of IP ranges for your subnets. Now, once again, as a developer, even if you weren't that familiar with infrastructure, if somebody helped you set this up, you'd probably be able to come back and say, I know what this does. And also, let's say we decide we want to change some of the subnet ranges. This will then be a file that's committed and changed with a comment, and we can go review the change over time in history. And also just quickly to show you what the ECS cluster creation would have looked like. Fairly simple. Nice. So, sorry, I have slight duplication over here. Cool. So what do we want to do with infrastructure as code in terms of the goals? Is the first one is we want to make our infrastructure changes repeatable and predictable. So remember that example I showed you where, or I spoke of, where you set up dev and you go and develop your application, everything is working, and at that point in time, and this happens often, they come to you and say, okay, cool, we're glad the dev works. Can you please roll this out to production? We've got some people that want to start using this tomorrow. You've done it on dev, so surely you can do it on production quickly, right? And then you go like, yeah, sure. And you hope you do it correctly, because you might have had notes on a notepad next to you in terms of what you did. You might have kept a diary somewhere in a text file, we hope. And if you had to do this, again, you might make some mistakes. So it's not easily repeatable, and it's not predictable that you won't make mistakes. Whereas if you use a tool, for example, infrastructure as code, that'll allow you to say, cool, let's set this up so that now when I go to production, I know everything that I defined on development is in that same file. There's some config changes to it, but then the exact thing is deployed to production. That makes it repeatable in production. And I can guarantee you that when you have that discussion saying, hey, listen, don't worry, we've got this sorted, your manager is going to be a lot happier. Second benefit is that you release your infrastructure changes using the same tools as your code changes. We spoke about this earlier when, for example, you want to make some kind of infrastructure change. You commit that text file with a commit message. Someone on your team reviews it, or another team reviews it. And then once approved, it rolls out using your same CI/CD pipeline as you would for your code. It means that you don't have to worry about clicking around, getting access to the console, all those fun things to try and roll it out. The third benefit is that you're able to reproduce your production environment in a staging environment or development environment. It makes it so much easier to do testing and make sure that everything is the same. And what we mean by the same is that you might configure your system to have a load balancer with some fleet of web servers behind it, and then some kind of database that those web servers access. The difference between production and development, for example, could be that production has 50 web servers and a database server with 16 cores and 256 gigs of RAM, where development only has 2 web servers and a database server with 1 CPU and let's say 4 gigs of RAM. The only difference in terms of your config in your infrastructure as code is the configuration file that you pass into it when you say, please go create this environment for me. And those will be 2 versus 50 and the size of the database difference. Another fun tweet that I found, unfortunately I couldn't get the source of this, but basically the tweet in question went something like this. It said that developers love great documentation because it makes it easy to build new systems. Developers love creating great documentation. And then lastly, only one of these statements is true. Now, the thing here is that we all have this, and we probably have hit this problem where we love to use great documentation because it enables us to go faster and actually build something quicker than if we didn't have great documentation. But setting up this documentation does take a lot of time and a lot of effort. So we have to worry about, is it actually, is the documentation we create good enough, and do we have the time for it? But if we, for example, use infrastructure as code, let's take a look at our documentation and how this would work. So a new person joins a team. They ask you, how do I create this one thing? Or they ask you, hey, why are you using a FIFO, which is a first in, first out queue, instead of just a normal queue? Wouldn't it be nice if you can respond to that person saying, hey, listen, well, here's the repo, go have a look and you can see exactly what's done. And also, if you want to find out more about why we use that first in, first out queue, there's the repo, the infrastructure sitting next to it. If you can look at these following commits, you can see where we went from a normal queue, and then we found out that there were these 1 or 2 edge cases. This happened, then we figured out we need to change our application code a little bit, and then finally settle on a first in, first out queue that solved the problem. And everything is documented in the commit messages, as you would with normal code. And over time, you build this up, and then everybody's able to understand how your infrastructure evolved. And it's much easier then for people to reason about what changed. So that flow that I spoke about, writing code, having a teammate review it, building and testing it on some kind of CI server, and then ultimately deploying it. And then once deployed, you're able to also measure your code to make sure that it's performing correctly and it did what it's supposed to be doing. And then you repeat the cycle where you start improving it. You do that exact same process for your infrastructure, using the same tools, using the same repo, putting your infrastructure definition right next to your source code. So that's a good place to start. Now, I'm going to touch a little bit later on exactly where, for example, these tools should end. Basically, it boils down to when you get to the edge of, for example, you've got your load balancer and you start defining which services to deploy. That deployment mechanism, because we're using declarative language, you don't want to use that part still for this, because if I change that declarative change, some of the tools don't have nice ways of swapping it out. They'll literally just start replacing it in place, and that might not be the best strategy. And we'll look at some of the different deployment strategies, for example, blue-green, as well as a canary deployment at the end of this talk. So let's start talking about virtual machines, because often people need to deploy the code somewhere, and this is where a lot of people start before they hit containers. So a VM, what are the things you want to consider? The first thing is, what operating system can I use? So let's say I joined this new organization and I want to deploy some code and I need to know, what host am I going to be deploying it on? First question that comes into, what OS do we use here? I might be used to Ubuntu, but for some reason this company is using Gentoo or, for example, Fedora. So you want to know what operating system you can do. Then let's say something happens and you need to patch that OS. How do you go about patching it? You want to know what version of Java you can, because we're writing applications in Java, but we've got many different services and not all of them use the exact same version of Java. Then we get down to the package level, and it's like, what packages are we using? Are we using OpenSSL and are we using LibreSSL? Now, this is something that actually bit me quite badly a few years back. I was busy migrating a Ruby app or a couple of applications, and I decided to pick Alpine Linux. And at that point in time, they were busy transitioning from OpenSSL to LibreSSL, and I didn't pick this up because I didn't read the documentation. So I went from everything is fine today to the next day, everything is broken, and it took me a couple of days to figure out what exactly was going on. So part of what I'm showing you now is what I learned from that whole experience, and also how to build images properly and using automated tools for it. Then the famous question. Apologies if there is a Bob on the stream. I just use this name when I do presentations. So what happens when Bob leaves? Bob was the person who actually set up that perfect Snowflake server. It took him 2-3 weeks to set that server up, and nobody else has any idea how to set that server up. And if Bob isn't here, we can't replace that server, which is obviously a big risk. So how do we, handle that? And then lastly, fun one, there's the CVE. What now? So the CVE is when there's some kind of vulnerability that has been disclosed for your operating system, and you need to now go patch everything. You need to do it quickly, because let's say you are affected by this and it is a high severity one. You want to patch your servers as quickly as possible. So how do we enable you to do this, firstly, quickly, and secondly, safely, without worrying? So firstly, you need to change a little bit of culture in your company. So you have to chat to your developers and make them understand that if you build it, which means you're building any kind of system, you must also maintain it. That means you need to patch it, you need to fix bugs, you need to monitor it, make sure that it's working properly. You shouldn't be just writing the code and throwing it over the fence to someone else. I did warn you that I'm going to bring a lot of DevOps things into this. So what you can do with automation is that you can create a golden path for them. And what we mean by this is that you can create, for example, templates and automation tooling that allows you to easily spin up new services, use CI/CD pipelines, use configuration management, secret management, all of that in a nice, easy way. And you might want to make the right way the easy way to do things. The thing here is you don't want to force developers. I was in a situation once where I thought, hey, listen, let me put all the automation in place. And, I'm just going to tell the devs, look, here's the new system. Boom, done, mic drop. And the pushback was hard. The reason is that I didn't socialize the idea with the development teams beforehand, and while this did make their life easier once they understood how it worked and once they were comfortable with it, initially they weren't happy. So what you do want to do is you want to say, here's the golden path, this makes your life easy and better, and this is the recommended way you do it. But if you decide you want to do it on your own way, you don't have to follow the golden path. You are welcome to walk barefoot through this other area, but then you're on your own. Understand that you then need to, if you want to do different automation, you need to also support that automation. So it's just a little bit of a culture thing there to think about. So how do we go about building images? Well, if you haven't looked at an open source tool called Packer by HashiCorp, this is one way to build AMIs. We also have a tool called Amazon EC2 AMI Builder that you can use for it. Packer's been around for a few years, and the reason I show this to you is that it's just got a plain JSON config file. So even if you've never had to build a virtual machine image automatically, you might have done it by hand before. So let's say you did it by hand. You would probably spin up an instance, you would then SSH into it, you would install some packages, then you'd install some runtimes, let's say using Java, which we're going to be using in today's example. You might spend, I don't know, an hour or 2 or 3 actually setting everything up. Then you snapshot that server, and then you say, okay, cool. Well, this is now the base image that we can use everywhere else when we spin it up. And then let's say you need to patch that server, same process over again, a couple of hours every single time. So this is something that's probably a good place to start automating, because you can save quite a bit of time here. So getting back to how Packer works is, if you look at this JSON configuration file, that line that I've highlighted there is where we define what our starting image is. And in this case, we're going to be doing a lookup for an 1804 Ubuntu version, and you can see it's wildcarded. And a couple of lines down, we say the owner is a specific account ID, which means we only look at canonical for this, because there are multiple public images that we can use, but we want to use the official canonical one. And we also say that we want the most recent one. So we do a wildcard search, and whichever one is most recent, that's the one we're going to use. Then the next part to highlight here is that at the bottom, this is the name that we're going to give this image once we've built it. We're going to call it DevConf Golden Base, and we're going to give it a timestamp. Because let's say we rebuild this image once a week on, say, for example, a Sunday morning. That'll have the most recent timestamp on there. So we will always know what was the latest Golden Base image that we built. Then we go ahead and, for example, in this case, we are updating apt, and then we're upgrading all the packages with the -s to force it to happen. So what this will do is it'll give us a fresh Ubuntu image with all the latest packages installed. And even if I go back quickly, if you've never done any kind of virtual machine image automation, you can probably follow what's going on here again. And once again, this is just a JSON file, and this also goes into a repo. And we look at how to put this in a CI/CD pipeline as well. So this makes it very easy to actually create an AMI. And that's nice, but where does the use come in? Well, let's now say we want to start making it easier for our Java developers. And we say, okay, we'll start off with that DevConf Golden Base that I just mentioned. Similar search, the only difference is a couple lines down, you can see that we're now looking at the owner's self. So we're only looking at AMIs inside our own account. And what we're going to do then is we're going to rename it using a variable that we have over here, which is the Java version, in this case 1.901b. And then we're going to call this one is called the DevConf Java with that version number with the timestamp again. So similar to the previous base image, we are now creating a Java base image based on that original base image that we did. Now you could also go and install some base tooling on that. Let's say you've got a suite of command line scripts, or you need some CLI tools on all your instances, or some kind of like monitoring framework that you want to install on all your instances. You can always do that in that base image, and then any subsequent image that you build off it will have that in there. And now if we look at the actual steps that it does is, you can see that we are defining some kind of source file, and then we're running some kind of shell commands, which is to list some details which we might want in the CI/CD pipeline's output. And then lastly, the highlighted line is where we install OpenJDK 8. Now this one, I didn't use that variable all the way through, but you can use a second variable with specifying exactly what's the package name that you want to install. And where this becomes super useful is that when you start looking at how your VM structure looks like, is that you start off with that golden base at the bottom, and then you can start building different language ones depending on what service you want to be dealing with. And then even on a specific language, like let's say Java, you can have different other base images like 1.11, 1.6, or 1.9, which means that when a developer comes along and says, listen, I want to build a new service, you say, okay, cool, well, this is the golden path, this is where we make it easy, these are the ones you can easily use and grab, and they can go and look and say, okay, well, in this case, I actually need Java 1.11 because there's some new features in the language that I need. So let me grab that and go, and then I don't have to worry. So now that we've built these images, there are a couple of things you need to worry about and build into your testing portion of your pipeline for this. The first one is it able to boot? As a warning here, a couple of years back again, built the image and I made a mistake somewhere in the config, which meant that the image, as soon as it came up, it crashed and then it just shut down again. And what happened is that because it was an auto-scaling group, it would come up, 60 seconds later, it would die, new one. 60 seconds later, new one. This went on for about 2 hours. And at that point in time, the cloud billing system was still on a per hour basis when you spin up an instance, not per second. So I quickly racked up quite a big bill, and I had to learn quickly that, okay, this is something important. You have to test your AMI. Can it actually boot? Second step is, are you actually able to deploy your app onto this instance? Because it doesn't help if you spin up an image and your deployment tool can't work with that image. You don't have the right, let's say, SSH keys, or the agent that does your deployment for you isn't running, etc. So make sure you're able to actually deploy your app on that AMI as well. Then thirdly, you want to be able to make sure that it can run your app. So at least have some kind of testing in your pipeline to make sure that app can start on the specific instance. Let's say your app is compiled for Java 1.11, but you accidentally installed Java 1.9 on this. You should have a tester to make sure that, hey, listen, this can actually work, because otherwise you're going to have a bad time. Then also you don't want to have any of those CVEs, so do some kind of CVE scanning. And this does have an asterisk because there are some caveats here. For example, some CVEs aren't critical. There are medium level warnings. So let's say a random example that I remember is that ImageMagick had some kind of security feature or a security issue. If you don't use it, but it's still installed in the operating system, then yes, that is a risk, but it's a low risk because you know you're not using it so that it can't be exploited. But a better way to handle this is actually say, well, why don't I go back to that base image? I know I don't use image magic, so let me uninstall it from the base image, then I don't have to worry about this. So that's a better way. But you can put some whitelisting over here to say, listen, ignore these couple of CVEs because I know after investigating them that this is not a risk for me. So going back to that little grid we had in the beginning, if you think about having to patch servers on a weekly basis, because think about how often these CVEs come out and how often new versions of runtimes and things come out that you want to patch, you probably want to do that. You're probably doing this on a weekly cadence. And if you're quick, you can create one in 1 hour. So if you spend 10 days on this, and remember, I just showed you some JSON files, will probably make it a little bit easier to do than 10 days. You can save quite a lot of time over the next 5 years. So this is a very good time to invest in some automation. So now that you know how to build those, what you want to do is you want to have some easy deployments using CI/CD automation, or not for deployments, but how about for image building? So this is just using AWS Code Build. And what you can see over there is 2 lines where I actually build these. So I firstly build the DevConf golden image, and then I go and build the Java version of it. And what you can do once again is this is just text. You put this in, and as you then create more and more different images, they'll just be different JSON files. You just add them in the right order over here, and you end up with that nice nested ability to build different images. Now you've got the images. Now the question comes in, how do I roll out these new images? Well, good news there is there's a nice way where you don't have to do a lot of work. In fact, you have to do very little work. And how it works is that, you remember how we defined our infrastructure using code? Now this is where we've got an elastic load balancer that sends traffic to 3 individual instances. And those instances are created in an auto scaling group. So for auto scaling group, you tell it that, hey, listen, here's a base image, and I want 3 copies of it running in the following subnets. Please go make it happen. And then what the auto-scaling group will do is it'll say, okay, cool, let me spin those up for you. And there's some configuration like if I need to create more, create less. So let's say we've got those in place. Then what we do is in our infrastructure as code, we can go do a lookup and say, listen, what is the latest AMI with a specific filter? Like we did the search in Packer, we now do that search inside our infrastructure as code tool. And we say, okay, cool, go grab the latest version. So then we update our load balancer. So now we're pointing to the newer version. So previously, this image was built on the 1st of Jan this year. Now we're using a template that was built on the 29th of Jan. Then what we tell our auto-scaling group is, please double capacity. Because when it scales up, it now uses whatever config it has, which points to that new AMI. Now it spins up these 3 new instances, and then your normal deployment system kicks in and deploys your code and starts up your code, and your load balancer starts sending traffic to it, but now running a double capacity. Then what you do is you just tell your auto-scaling group, okay, cool, scale down again. And now we've got the fresh images running. And this is a very nice way to actually refresh your fleet on a weekly basis. For example, you build your golden images on a Sunday. Then on Monday morning, you schedule this to happen on the development environment because you know likely you'll be around on the Monday to look at this. It upgrades the entire fleet for dev, and if there was any issues, you can then address them because there might be something that your test missed or some strange package that was released that had some kind of effect that you couldn't test. Then you schedule, for example, staging for the Wednesday, maybe skip a day so that if there is some kind of thing, something that you have to fix, you have at least 2 days to catch it. And then on Thursdays, you do production. And also, if you're in a highly regulated environment, imagine having that conversation with the auditor about disaster recovery. And you tell them, instead of like, oh, here's my backup server, I'm going to copy it, and this is the process, you go, well, we refresh our servers and rebuild them every single week. Isn't that nice? And then also, remember, I spoke about CVEs. Now imagine the CVE comes along and is critical enough for you to want to replace your instances immediately. All you would do is go into that config file inside for the Packer config file, change whatever you need to actually patch the specific package that needs help or needs to be patched for that CVE, and then commit that file. Then you kick off the job manually that would normally automatically run on Sundays to build a new base image and all the subsequent base images. And then all you do is you trigger the scaling event, scaling up with double capacity and scaling down again manually. And then you patch everywhere. You don't have to worry because guess what? This is something you do every single week. So the risk of something going wrong is a lot lower. So just think about how nice that would be, and you don't have to worry about patching and worrying about that server. Because I read an article recently where it says like, what scares you most? Rebooting a server that's been up for 5 days or rebooting a server that's been up for 700 days? My money is on the 700-day one. So this is now pre-configuring everything. What we now need to look at is like, where do config management tools fit into this realm? So I mentioned earlier using Chef, Puppet, and Ansible. And I use all of these at some point in time. The most time I spent was with Chef. The problem I found with these, especially in the cloud world, is that they were built in a time when we had a lot of on-prem services, and those servers were very long-lived. So you would spin up the server, and also because it was a fairly big server, you would have quite a lot of things installed on it, complex configurations, and that's where these tools excelled, and that's what they were built for. They were really good at that. But now in the cloud world, what I showed you now with being able to do with Packer, that's not that difficult to do the configuration. There are some configs that might be a little bit tricky if you, for example, have to get cluster information, which you can only get once the server's up and running. But in general, I found that you don't have as much need for them anymore. And the reason for that is that, let's say you spin up an instance and then you start configuring it after it's spun up. You might run into the following problem, which is once again that same architecture where you've got your elastic load balancer, and you've got three servers in place. Now these are a little bit older servers. Specifically to illustrate this point, we have ones that were built on the 1st of January 2019. And at that point, the configuration management tool kicked in and installed specific libraries, used specific things to install. Now something goes wrong and one of the instances goes down because let's say it just had a memory fault, or the underlying hardware broke, or something happened that forced it to be replaced. So now we spin up a new one, but now this one is spun up in, let's say, Feb. So more than a month later. The packages that were installed by that configuration management tool might not be exactly the same unless you pin every single version of every single package that you're using. And that's something that takes a lot of time and might cause a lot of complexity. And even if you did do that, at a later date, that package might not be available anymore. Because let's say it was a package that had some kind of issue with it. They might decide to remove it from the operating system's library for upgrades and only have the next best version. And then if you did pin that version, you have that problem. So this is something you're going to run into if you do use configuration management tools. So my recommendation is that unless you've got a specific need for them, rather go with pre-built images and spend a bit more time on that to get them to the space you want to. It'll save you a lot longer time future. And also when we get to containers, which we will in a second, you probably don't need these tools because you end up with hosts that are very lean in the sense that they probably have Docker on them and maybe one or two other monitoring tools, but that's about it. You don't have a lot actually running on the host. Now, speaking of Docker, we've all had this problem where it builds a machine and we push it to production. So this is actually amusing because I did work with a developer at one point that liked to work from 5 a.m. till 3 p.m. and he would commit code at 5 to 3 and then leave. He didn't check if that could build. He didn't check if it actually passed. But we'll get to that in a bit. And it was not a fun one, but because this was his mindset. It builds on my machine, cheers. And then just a little bit of fun. This is where Docker comes from ultimately. So containers. We probably are busy running and using some containers in some fashion at work. And what I just want to do here is before we just jump into containers, because I know it is very popular at the moment, just remember this. This is quite a fun cartoon. So this is a little cartoon where typically the pointy head boss just throws in random words and says, well, this should solve a problem. Now, part of this is just remember, if you are using a specific tool and it's the only tool that you use, it's going to look like a golden hammer. And you're going to try and solve every single problem with that one tool. And this next picture usually has a caption saying, look, I deployed my blog on Kubernetes. And I know Kubernetes is super popular at the moment, but I always caution people saying, listen, yes, I know it's popular, and yes, I know it solves a lot of problems. But the question is, it brings a lot of complexity, and do you want all of the complexity for the problems that it solves? Do you have that level of, let's say, platform that you're building? And if the answer is yes, then by all means, please go for it because it will make your life easier. But if you don't have that complexity, you possibly don't need it. In fact, if you look at this is one of our Amazon warehouses. So obviously Amazon is big, but if you go back in time, this is what our initial Amazon website looked like. And this backend was a single monolithic application that we ran. It had one binary, and we had configs that we could spin that binary up to fulfill different roles. So for example, in the one state, it would be, let's say, the purchasing system. With another configuration would be our ordering system. And it was a single monolith. So the one thing I want to caution here is just remember, monoliths are okay. You don't need to go microservices on day one, especially if it's something that might not need to scale or might not grow to be super complex. So just remember that, please. It's useful. So what we're going to do here is that we have the same nested builds as we had for VM images. So remember this one that I showed you where we had those VM images? You can literally just strike out VM images and put containers over there. You want to have a base container that you use, and then from there you start building containers on top of it. Once again, you want to try and standardize things a little bit in terms of what different containers you use. You don't want to just grab the latest Ubuntu 18.04. The reason for that is if I build that container today and then I do a build tomorrow again without my code changing, that might not be the same image, because that image is updated behind the scenes on that public repository that you are pulling from. So always set up that you pull that base image in first, and that's the point where you build everything off from. The second reason you want to do that is, let's say for some reason that image is pulled at one point, or some package is pulled that is based off on. And a good example here is when a lot of Node applications broke because the developer who built the left pad library, a lot of things were dependent on it, and for some reason he decided to pull that library, then a lot of things broke. But if you had built your base image and you kept it in your own repository, you would be able to continue building off that base image without having to deal with that complexity. So think about always having your own nested or own containers first, and then building off that base container from there. And the good news here is if you follow the same process, I'm not going to dig into how to build Docker containers too much because there's great documentation online, but if you compare that to, for example, a successful image that you built, is firstly, you don't have to worry about can it boot, and you don't have to worry about can it deploy your app because your app is inside the container and that's how it runs. You still have to worry about can your app actually start up in that container, and also does that container have any CVEs. Now, just quickly one here, I know that Docker is, a lot of people use Docker, but remember, Docker still needs to run on something. That something is usually a host. You are often responsible for maintaining that host. So think back to the first example. You probably want to know how to build a VM that actually the Docker container runs on, and how to actually update that image when you need to. So just remember that. You will always go back to how do I spin up an image and how do I actually patch that image. So deployment patterns. First one is that we often see people deploying Docker using latest. And for those not familiar with that, it means that I pull the latest Docker container, and it's also known as deploying YOLO. So YOLO being you only live once, which is a little bit risky and dangerous. So what do we mean by this? Well, let's look at the typical latest deployment. I've got 5 containers running with the latest tag, and that was the last version that was built. The hash for that image was 5 ones. We're just making it easy for now. Then someone comes along, they push a code change, and we build a new latest image. This one has a SHA of 5 twos, just for instance. But then after that image was built, but before we actually deploy it, there's some kind of scaling event. So we need to launch new instances. Now we just pull latest again. Because remember, when you pull latest, that is done at the time when you execute the command. So if there was a newer build, it'll grab that newer build. Now you've got this mismatch of 5 old versions of the code with 3 new versions of the code. And that's not a great experience because there might be something that breaks in there, or different behavior and is not controlled, and things can go wrong. Definitely don't want to do that. So what you want to do is you want to use that hash. So when you do your automation for your containers, make sure you always specify that SHA-256 hash that is generated when you build a container. Because if we look at this process now, we now specify that tag. Someone builds a new tag. Then we have the scaling event. But we scale up using that tag, so we know that we get the exact same version. And then when it's time to do the deployment, then only do we swap out all the different containers. So just remember, this could be a problem for you. Then lastly, a nice tip. The best automation is no automation, in the sense that no automation that you have to do. So there's this awesome quote, which says, I would not give a fig for the simplicity this side of complexity, but I would give my life for the simplicity on the other side of complexity. So what this means is that, let's say I've got a simple task, and I have a simple solution to it. That is not that impressive, and that's not that good to have. If I've got a very complex task, like orchestrating containers and doing a blue-green deployment or a canary deployment, and I can do that easily and simply, that is worth quite a lot. I want that simplicity to do this complex task for me. And what I want to highlight here is I'm going to be using some AWS examples, but have a look. There are a lot of different tools available, and your cloud provider will probably have some kind of automation that you can make use of. So the first one is, let's say you want to spin up an entire cluster to host your containers, and a build pipeline to actually build and deploy those containers. You can do this, for example, with 4 commands using the CLI tool that we've released. This takes a very complex things and boils it down to a very simple way to do. So it makes it very simple to do. And you don't have to do all the automation because it's done for you. Also, when you are automating your projects, make it easy for people to do a build and to do a test. That example I spoke about of the developer that did the 5 a.m. till 3 p.m. shift. One of the reasons he did that, where he committed his code and then just left without building or testing it, was that it was hard. He could build locally, and he did it most of the time, but sometimes he didn't even do a build, and then he had syntax mistakes. But he definitely didn't run any kind of integration test, because his view was that it's too hard to do. There are like 50 million steps to follow, and it takes too much time. What you can do is, I've here used the make file, and you wrap all of your commands that you need to build your project as well as test your project inside that make file. So that when you check out any project, you say make build and make test. Doesn't matter if this is a Java project or a Ruby project. And then if I, as a Java developer, comes along and I needed to check out, for example, a Ruby project because I want to make a change, I know that, hey, listen, let me go make the file change that I think solves this problem. Then I can run make build and make test. And then I know that it works. So this is also known as the check and dance. So it makes it super easy. And remember that golden path, you want to make the right thing, the easy thing to do. Then all projects, you know that as soon as I check it out, I can make them build, or I can make build and I can make test, and it just runs. So it makes it really easy to do that. Then on the deployment side, and this is an example of a blue-green deployment. So what we can see is that we've got the old version, which is blue. Then we come along and we deploy the new version, which is green, but no traffic goes to it. Then we start at a point where we switch all of the traffic to the new green version once it's up and running. And then finally we go and shut down the blue version, so that if something happened where we saw that the traffic to the new version wasn't happy, we could shift it all back to the old blue version again, should something go wrong. And now remember when I said the best automation is the automation you don't have to do. If you look, for example, at how code build and code pipeline works, is in code build, you literally pipe as part of your packaging step. You take that hash of the container along with the container name and put it inside a JSON file. So literally that JSON file only has container name, hash. That's it. And then you pass it on to code pipeline. It will give you that blue-green deployment that I just showed you for free. You don't have to do anything. It'll automatically spin up the same number of instances of the old version that's currently running. Wait till those containers are in a steady, healthy state. And then once it sends traffic to it and sees that it's working, it'll automatically shut down those old ones for you. So this is a nice way to utilize automation that you don't have to do. So it takes a complex task and make it super simple for you. So think about that. Sorry. Also super important is that there are additional features coming out the whole time. I spoke about Canary deployment. And for those not familiar with a Canary deployment, what it comes from is a canary in a coal mine, where you take something that gives you an early indication of, is there an issue or not? So you deploy one copy of the new version, and then you send, for example, only a quarter of your traffic to that new version and switch off one of the older versions. And ultimately, over time, what happens is, as you see that nothing is wrong, you send more of your traffic to it. And ultimately, you send all of your traffic and switch off the old version of it. And once again, you can get this kind of Canary deployment with a single config that you add to that code pipeline that I showed you, where you tell it, please do Canary deployments with specific minute increments or however you want it. There are a couple of config options available. So once again, you don't have to do any kind of automation. It's done for you. So remember, you can leverage this and save yourself a lot of time, because you definitely do not want to build this with bash scripts. Ask me, I tried. I thought I was being smart, and as soon as you start thinking you're being smart, rather go look for a better solution or tool to do it for you, because you're probably not as smart as the people that build these kind of tools. So a little bit of reading homework here at the end when we're wrapping up. First one is the Phoenix Project, which is a novel about DevOps and how to transform a business. It's not super technical, great read. It's about 200-300 pages. I would highly recommend you read at least this book if you don't want to read both. Then Accelerate is by those three authors, and Nicole Forsgren actually did a PhD in DevOps, and she started off the State of DevOps report back in 2014, 15, 16. I can't remember exactly how many years ago it was. But basically what this does is that report asks a lot of questions to developers at different organizations, and then based on the information there, they look at the clustering of specific answers and see, well, we've got a couple of questions that cluster around this one point, and if we look at that organization, we see that it's a high-performing organization. So that's likely one we want to figure out why they're doing well. Another clustering is where it is not doing well. So go have a read of this book. A couple of great takeaways for me. It was mean time before failure versus mean time before recovery, where mean time to recovery is a lot more important. But we can chat about that at a future time. So with that, I'm going to say thank you for attending today's session. There will be a little bit of time for a Q&A, and I'm available here on Zoom if you want to throw me some questions at me. If you do want to ask me some questions afterwards, there are my social handles on Twitter and LinkedIn, and I'm also going to be streaming on Twitch a bit more in the near future, where I build things and build some demos if you like that idea of live coding and chatting to me. So thanks. I hope you enjoyed this session, and remember there's another session that I'm doing at 4 o'clock if you want to join. Thanks. Cool. Howdy, people. Let me know if you've got any questions. I'm also answering them on Slack at the moment. So yeah, let me know. I just saw the feed come through on the other one. There's a little bit of a delay. I'll try and smile more and look friendly. Cool. So there was a question around what do you use to measure and on every commit? So the answer that I gave previously on that is that it depends what you're trying to measure. So let's say you are trying to figure out if a database query is going to be faster, then you would use time and maybe something like the number of table scans that it does. Have a look at the execution plan. If it's something a little bit more abstract, like mean time to recovery or number of failures in production, you would use obviously time as a measurement for how often or how long it takes to recover. And for bugs, you'll use a number of bugs. Cool. Then we've got another question here that says, please share information about non-FIFO queues. So just quickly, FIFO queues is a first in, first out queue. And if you look at what we have at AWS, which is SQS, which is simple queuing service, the default queues are not first in, first out. They just, as the messages come in, they become available. But you sometimes have that specific need where the messages have to be processed in order. So then you have to use what's known as a FIFO queue, which is the first in, first out. So the first message you put in the queue on the one side travels through, and that's the first one that goes out on the other side. And the messages will be processed in that order. There was another question around how does Packer differ from Docker and Kubernetes? And the answer there is that they're all three different things. So firstly, Packer is a tools that helps you build images, whether it's a VM image for, let's say, VirtualBox, VMware, Amazon Linux images, any other like virtual image. It can also build Docker images. So it helps you with the building of those images. Then Docker itself is a standard for containers that defines how the actual file looks like that contains all the necessary binaries and how that interacts with your system. And also it has a CLI component to it, like how you interact with the actual Docker agent that runs the containers for you. Then Kubernetes is an orchestration tool that takes care of the lifecycle of your containers. So you tell it what containers you want, how many, and what configuration you want them to run, and then it makes sure that those containers are deployed and actually kept running as well. And it's used as a platform to build other platforms because it's got a whole bunch of other features around managing container lifecycle. So there's a question that says, was the move from Terraform worth it? And what was the major advantage? In terms of my history here, so I started off with Bash scripts, then I moved to CloudFormation, which is at that point in time was still JSON based. So you had this massive few thousand line JSON files. And then from there, I moved over to Ansible. The reason I moved off CloudFormation is that I ran into it becoming a bit complex because there wasn't an easy way for me to reference things at that point in time, and I didn't fully understand how it worked. So obviously I blame the tool, even though it was me. Then I moved over to Ansible, had a lot of good fun with Ansible, but also got to a point where at that stage, Ansible was still fairly new. And it had this feature, well, I wouldn't call it a feature, but the way Python works is if you had an undefined variable, so if in your complex Ansible setup with multiple rows and things, you didn't define a variable, you made some kind of syntax mistake, Ansible would just keep running. And what really broke me there is that you had to sit there and stare at the console for that little pink purple message that flashed by that said undefined variable, because it would just keep going and going and going. And Ansible at that point was imperative style of infrastructure as code tools. So it started off and just ran everything again from beginning to end. It didn't take into account what the current state was and what you told it you wanted. So I wasn't that happy. Then I moved on to Terraform, which is declarative and uses JSON-like syntax. And I really enjoyed it. I had a lot of fun with Terraform, and I actually still use it quite a lot. Then in terms of moving on to CDK, CDK is a fairly new product. We launched it on 7 July last year, and I've been spending some time with it, and it's different to Terraform, but I'm enjoying both of them. So if you have to pick right now, pick either of the two, depending on which one makes the most sense to you. So the question here is, do I prefer Terraform style generic approach or using the provider specific tools? I'm assuming here it's the question of, do I prefer Terraform above, for example, the CDK or CloudFormation? It entirely depends what you're trying to do. Certain things are easier with some tools, certain things are easier with other tools, and also it depends a lot on your background. So for example, for me, Terraform, because I started using that point, made sense and it was a good fit. But if you're a software developer and you've never done a lot of infrastructure or sysadmin type tools, Terraform might feel a little bit weird in terms of how you're working it, and something like the AWS CDK, which uses a programming language that you're familiar with, like Java, TypeScript, Python, Node, is just something that's easier for you. So it entirely depends. I actually use both, and it depends entirely what I'm trying to do. If I'm working on an AWS specific project, I tend to actually do both of them because I want to see where the two differ and where they work the best. But play with both and pick one that works for you. Cool. It seems that we've had all the questions that were asked during the session. So what I'm going to do is I'm going to hang around in Slack. I've got another talk coming up at, I think, 4 o'clock on stream 6 on building or resilient and availability architectures for cloud systems, if you're interested in that kind of like architecture talk. But I will be around in Slack to answer any questions if you have any more. So awesome. Thanks.